Aloha, everybody. Thank you, Matt, Andrea, Kyle. Great presentation. Thank you, guys. Aloha, everybody. Thank you for being here with us today. Can you see my slides? Okay, awesome. I got those slides from my colleague Emily Kirk on Kauai. So I'm acknowledging her also on the authorship of this presentation. We're gonna talk about basic IPM, integrated pest management strategies. And what's a pest? A pest technically anything that's gonna harm your focus point. An idea is honeybees. Everybody loves honeybees, right? But as far as the honey, but then if they are in an area impacting the crop you are working with or impacting the work you will be able to perform, they become a pest also. They become an issue as well. Although we want to protect the honeybees, but in that situation, they become a pest. So any insect that's in the wrong location causing issues that become a pest. What is integrated pest management? Integrated pest management strategies, they are a collective action that they are designed to reduce the reliance on one type of methods and integrating multiple ways to reduce the impact of that pest on our crops. This way, we are not letting any pest to build, for example, resistance to chemicals because we are using multiple ways of that control and prevention. The practices can be cultural, physical, biological, and chemical methods. Now, somebody say, okay, IPM, so I'm not going to use chemicals. You can still use chemicals, but then what kind of chemicals, how much of it in connection with the other methods, that's what's going to control it. Again, the goal is to minimize the economic, health, and environmental risk of that pest that you are trying to deal with. In many cases, which is typical in life, you will not be able to eliminate that pest completely. We have good examples. COVID, how much they tried to stop it. At some point start evolving, we ended up dealing with it rather than being able to eliminate it. So the same thing with pests. And also they are part of an ecosystem. Pests, yes, they are harming because they want to live, right? So they feed. They feed sometimes on the crops that we want to protect. But that doesn't mean they don't have other functional benefits in the environment. So that's why the idea of the IPM is to minimize the impact rather than elimination. And why the IPM? IPM because after the Green Revolution, when they start producing all those chemicals, what they realize that the relying on one method only is making the issue harder and harder. And there is an example here. You have, for example, aphids. You spray those aphids with one chemical. You're killing 99% of them. That 1%, because it survived, and you are happy with it, oh, 99%, that's a very good success, which is. But then that 1% remaining is going to start building resistance to that chemical. Over time, if we just continue using the same chemical over and over and over, the population will become more dominant by the resistant ones rather than the susceptible ones. So the recommended dose and application of chemicals will not work on those population anymore. Additionally, relying on only one method have shown in history big issues with what's called secondary pest or secondary infection, which is 1/3 of the most damaging insects in the US were originally a secondary pest. What that means, there is a one dominant pest. When we eliminate, it was, yes, it was harming our crops, but also it had a biological uh, symbiotic kind of relation or whatever, controlling the other pest from being able to be dominant, like feeding on it, stuff like this. When we eliminated the one that we thought is causing us the most issues, by eliminating that force, the secondary one had now the space and time to thrive and become a bigger dominant issue. So 1/3 of the most damaging insects in the US were originally secondary pests and only became major problems because of the use of the pesticides. IPM is based on a science of ecology, population dynamic, food webs, phenology, and periodic biological. So technically, what we are saying here is that IPM trying to mimic nature. In nature, there is nothing comes from just that one way. There is always multiple things comes from different areas and as a web. And that's what IPM. I'm using multiple practices to reduce the pressure of that pest and impact on my crop, rather than thinking of it as a one-way road. It goes by prevention, avoidance, monitoring, and suppression, if we have to. That's called PAM's approach. Prevention, avoidance, monitoring, and suppression. One method is to correctly identify crop damage and responsible pest. We need to be more familiar with the type of feeding and how it's related to that kind of insect. And sometimes you look for that pest, it's not there. Keep in mind, sometimes they are under the soil in the time, like for the daytime. That's when we are out in the field. They are below the soil. They are hiding there. They are night feeders. So knowing what kind of insect feeding type and impact will help us to determine it quickly and then have a better solution very quickly rather than try and error. Second, learn pest life cycle and biology. Why? Because if, for example, if I can, for example, at the larvae stage, I can stop the insect from becoming adult and that was going to impact my crop, boom, I will be able to stop that cycle and benefit from it. And right now we have very good example in Hawaii, CRB. If we can control the larvae when they are in the compost pile, we will stop them from becoming adult and going up to the coconut and feeding on the growth area. I give you another example. I grow dry beans and I have big issue with weevil. The weevils that usually when you have the beans in a storage, they start coming out from the seeds. Some people, what they do, they fumigate the seeds. Yeah, fumigating the seeds, you are killing the eggs, stopping them from developing. But that's not the issue. The issue happened when the weevil climbed on the plant and laid the eggs in the flower when the plants are just flowering. So controlling the weevil at that field stage, when immediately when there is a flowering, I'm gonna stop them from laying the eggs. The eggs will be in the seeds when the pods will develop, and then I'm gonna deal with it in the storage room. Because that's when they become, over time, they continue developing and then they come out as adults. So knowing what kind of stage is to stop that cycle is the best thing to do. Additionally, establishing action threshold. Why? Action threshold is related to how much of that pest can I control to make sure that they are not economically harming me without trying. Like, for example, if my threshold is 30%, if those insects are feeding on the leaves and there is like 10% damage to the leaf, 20% damage to the leaf, as long as the plant's still making photosynthesis, I don't have to spend more money to go and buy chemicals and labor to spray them. That's going to add into the cost and may not really give me back a good amount of revenue back with that 10% feeding on the leaves. However, if the feeding is 50%, 60% on the leaf, and that's impacting the photosynthesis, then it's economically viable for me to go get the chemicals and spray. to control the pest. So that threshold is very important. Monitor or sample pest population as well. Monitoring is very important because if you can detect it early through the monitoring, you will be able to stop it from causing issues to you rather than seeing the issue and, oh, what should I do now? It happened multiple times. I have farmers, they call me, and the plants are already showing symptoms of issues, big issues, like sometimes viruses that they were brought by insects. At some point, when the virus is very spread out, there's nothing to do. Like, yes, I will be able to identify that virus and the issue, but most likely the crops you'll not be able to harvest. So monitoring is very important in order to, if you see some issues immediately, I get ready for it. I stop it from making bigger impacts on myself. And there are so many tools. Notebook, cameras, hand lenses, they help you also to uh, uh, define the issue early on and find solutions quickly. Notes, sometimes things happen, right? Yes, we believe in, we trust in our brain memory, which is good, but because of the daily life and things in and out and talking about many things and seeing stuff overall, we will forget. So, notebook, hand lenses, camera, pictures right now, those iPhones with the memory, you will be able to take pictures non-stop, and that will help you to remember and go back again to it. Even saves with the date and location and all of that. Something really helpful. Let's take advantage of what we have. We are paying for the phone. Let's take advantage more of it. Choose and apply combination of management tactics. So, what we want to do, rely heavily on cultural as much as possible. Let's rely heavily on cultural. That's our base. Sanitation, crop rotation, cover crops, resistance cultivars, that's very important. If I can get a resistant variety with maybe not very much like the taste exactly as the one I prefer, I would rather to reduce the cost of my spraying chemicals and all of that. Physical, traps, barriers, mechanical remover, sanitation, stuff actually Cal actually was working on, like the cover crops. And when he mentioned, for example, the beneficial versus harmful nematode. Keep in mind exactly, not everything is harmful to us. In fact, beneficial nematode, they feed on the larvae of the rose beetles. You spray it on the soil, they feed on the larvae, they stop them from becoming adult, and all those holes of the feeding because of the rose beetles, gone. So there are some harmful, good beneficial ones, and there are harmful ones too. Biological, if we have them, unfortunately in Hawaii, because we are which is, it's fair because we want to stop the issues of coming maybe causing other issues, but usually that biological and pathogens and fungus, and now we see it in the CRB, there is fungus that can control it, but because it's not in Hawaii, it's harder to bring it in because we don't know what will cause us maybe issues over time. So, but if it is in Hawaii, why not? That will be actually good. Chemical, make it as the last and the least, as much as possible. Rely on sanitation. If you have infected plants, don't mow until that plant's in the field. Get it all the way out. That's a sanitation. Variety selection, right? Some traps, some early monitoring things, and then on and on and on till I go into encourage, for example, ladybugs. They are good predators. Some wasp also, they are very good. And then at the end, if nothing, I can go to the chemicals as well. And then evaluate results is very important because with results evaluation, you will be able to see what's happening, what worked, what didn't work, and then from there decide on where you want to go. It's very important because if we don't learn from our work, we will not be able to do better over time. That evaluation is a big one. I have so many examples with farmers. Evaluation helped. There are issues, yes, but then if we understand where did it came from, how we would have maybe stopped it and prevented, for the future we're gonna change our tactics to do better. Evaluation is very, very important. And thank you very much.